The science behind everyday phenomena can be both fascinating and enlightening, revealing the underlying principles that govern the world around us. Here are some common examples of everyday phenomena and the science that explains them. The sky appears blue on a clear day. This is due to Rayleigh scattering. Shorter wavelengths of light, blue and violet, are scattered in all directions by the gases and particles in the Earth's atmosphere. Our eyes are more sensitive to blue light, and the upper atmosphere absorbs violet light, making the sky appear blue. Leaves turn shades of red, orange, and yellow during autumn. As the days get shorter and temperatures drop, chlorophyll, which gives leaves their green color, breaks down. This reveals other pigments, such as carotenoids, yellows and oranges, and anthocyanins, reds and purples, that were present in the leaf but overshadowed by the chlorophyll. Ice cubes float in a glass of water. Ice is less dense than liquid water. Water molecules form a crystalline structure when they freeze, which is less dense than their arrangement in liquid form. This is due to hydrogen bonding, which creates an open hexagonal structure in ice. Airplanes can stay aloft and travel long distances through the air. Airplanes fly because of the principles of aerodynamics, specifically Bernoulli's principle and Newton's third law. The shape of the wings, airfoil, creates a pressure difference. Air travels faster over the top of the wing and slower underneath, producing lift. Additionally, the engines provide thrust, and the shape of the wings and body ensure stability and control. Soap effectively removes grease and oil from surfaces. Soap molecules have two ends, a hydrophilic, water-attracting end and a hydrophobic, water-repelling end. The hydrophobic end attaches to grease and oil, while the hydrophilic end attaches to water. This creates an emulsion, allowing the grease to be rinsed away with water. Rainbows appear in the sky under certain conditions. Rainbows are formed through the refraction, dispersion, and reflection of light in water droplets. When sunlight enters a water droplet, it is refracted, bent, split into its constituent colors, dispersed, reflected off the inside surface of the droplet, and then refracted again as it exits the droplet. This process creates a spectrum of colors arranged in a circular arc. You can get a small shock when touching a doorknob after walking on a carpet. Static electricity occurs due to the transfer of electrons between surfaces. When you walk on a carpet, electrons are transferred from the carpet to your body, giving you a negative charge. Touching a metal doorknob allows these electrons to jump, causing a small shock. The distinct smell of rain, known as petrichor, is often noticed before a storm. Petrichor is caused by the release of compounds from the soil. When raindrops hit the ground, they trap air and form tiny bubbles that burst, releasing aerosols containing geosmin, a soil compound, and plant oils into the air, creating the characteristic smell. Glasses fog up when moving from a cold environment to a warm one. Fogging occurs due to condensation. When warm, moist air comes into contact with the cold surface of the glasses, the air cools down and its water vapor condenses into tiny droplets on the surface, forming fog. Some organisms, like fireflies and certain marine animals, produce light. Bioluminescence is the production and emission of light by a living organism, resulting from a chemical reaction involving the enzyme luciferase and the molecule luciferane. This reaction produces light and can serve various functions such as attracting mates, deterring predators, or luring prey. Understanding the science behind these everyday phenomena not only satisfies our curiosity, but also enhances our appreciation of the natural world and the principles that govern it.